All right, so our example for today on the problem in front of you. Chronic users of cocaine need the drug to feel pleasure. A 3-year study compared an antidepressant called, I don't know, desipramine or something with lithium, a standard treatment for cocaine addiction, and a placebo. The subjects were 72 chronic users of cocaine who wanted to break the habit. 24 of the subjects were randomly assigned a treatment into each treatment. In this data, good evidence that proportion of successes is this data good evidence that the proportion of successes for all 3 treatments differ in the population of cocaine users. So I'm going to talk through more than I'm going to write because I've already got this written up that I can post again. I would be a little bit more specific here. What is our population? I think it's a little bit more specific than chronic cocaine users who want, because it's specifically ones that who wanted to break the habit. They mentioned that once and then didn't the second time, but it's really important if you want people that want to get better or don't. So population, I would say, are chronic users of cocaine who wanted to break the habit. Our null hypothesis would start with what? There is no difference in the distribution of. What are we doing the distribution of? So let's look at this. Where are our different populations? Are they on the left or on the top? So these are my different groups. So this is what I'm doing the distribution of. So this is my one categorical variable that I'm comparing. And what is this categorical variable? What does it call it? What is it called, this variable? One of two things. It should be hard. I'm not asking a hard question. If they relapse or not, or proportion of success, whichever way you want to call that. So there is no difference in the distribution of success rate, proportion of success, whether they relapse. Any of those 3 would work. For, and I would say the treatments of desipramine, lithium, and placebo. Does that make sense? So I need to list the different treatments or the different populations, but my categorical variable is just going to be one variable. Questions there? And then so I do the same thing for alternative. There is a difference in the distribution of proportion of success or success rate for desipramine, lithium, and placebo treatments. Alpha is not given in this problem, right? And this would say let alpha equal 0.05. So I'm going to go real quick now so we can do this in our calculator. Method is chi-square test of homogeneity. Random, yes or no? This one is important. Random, yes or no? What? The subjects were randomly assigned to the 3 different treatment groups. So they are randomly assigned to either desipramine, lithium, or placebo. Parentheses, random assignment, which we said it in there so you don't have to do the parentheses part. But this one is assignment, not selection. We go with that. Large sample size, all expected counts are at least 5, which we're getting ready to do. Independent condition, we would multiply what by 10? 72, so they're at least 720 what? Chronic users of cocaine who wanted to break the habit. Let's go ahead and do all of it in our calculator right now, because that doesn't take very long. So type them in. Where do I go to start? Second matrix. And you got to figure out if it's a 2x4 or 4x2. I usually just guess and check. Doesn't take long. Why is it a 4x2 or 2x4 and not 3x5? Why is it not a 3x5 or 5x3? Because I'm looking at 3 across and I'm looking at 5 down. So why do I not use 3 and 5? That includes my totals, and I don't include my totals when I'm doing my table in the calculator. Oh, I counted my numbers wrong, didn't I? It's 3x2. Makes me feel better while you are quiet. So it's 3x2. Type in your numbers. What do I do from there? Stat. Go where? Tests. Again, we have 2 options. Have we ever talked about GOF? Nope, so don't use it. So you go to C, your observed or A, your expected is going to be B. Calculate. Now, the problem I'm asking you, and I don't care if you do it right now or not time-wise, says make a table for expected count. Should that be hard? No, because what do I do now? You go to second, matrix, and then just click on B, and it gives you all those. Why are these numbers so similar and yesterday was not at all? They have the same totals, which means they should have the same expected counts. So when we ran our test, and I kind of told you to get out of it, so it's my fault. What did we get as our chi-square test statistic? 10.5. Our p-value is what? 0.0052. Now, did it anywhere give you the individual parts of the chi-square statistic value? No. So on a test or on the AP exam, it is likely for them to say something like, how much did yes lithium contribute to the chi-square statistic? What would you have to do? Let's answer that. That's a good one to answer. I don't know if that's how you spell it. So how do I figure that out? Say it louder. And what is our equation for that? All right, so I don't have it in front of me. For that one, what was our observed? What was our expected? So that gives me, this is the easy one. Oh, lucky. What's 16 or 18 minus 16? 2 is 2 squared. That's 4 divided by 16. So it would not be unlikely at all to be asked a question like that. So you just have to know how to calculate it, but you don't have to go through and calculate everything by hand unless I ask you for a specific piece. I do want to write out, whether you write it with me or not, the conclusion to this one because I've briefed that example. So this one would be we had a p-value of 0.005, so we reject the null hypothesis. And it's what? I'm gonna write alpha instead of going typing that right now. Which means we get what? Of what? I gave you options here, just one of them. Give me something to put here. What's our categorical variable? For I'm not gonna spell this. DEST. Nope. For who? And then hopefully that helps being able to at least see it once. Just like yesterday, I'll end up posting the 4-step for today so that you make sure that you have it to follow if you need it.